These types of questions aren't particularly common, but they do appear occasionally. So what they're dealing with is powers of roots of quadratic equations. Okay, so basically we're given a quadratic equation here, we're given that alpha and beta are the roots, and then we are asked to find out what this rather horrific looking thing is. Now, basically, the first thing you need to do is you do need to check, because there are two methods to do these. One is if the roots alpha and beta are complex, and the other one is if they are real. So you just need to do a quick check on b squared minus 4ac, and clearly b squared root 6 squared minus 4 times 1 times 3 is less than 0, and so therefore the roots are complex, and therefore we use this method. But it's worth doing this before you actually proceed. Okay, so we're going to be dealing with complex numbers. A couple of quick things, recaps on complex numbers, which we have already done in other videos. If you're not clear on complex numbers, take a look at the 3 forms of complex number video, and also take a look at the 16 must know complex numbers, because they appear all the time and they appear in these 2 questions here as well. Okay, so basically what we need to do when we have this sort of a question here, we will put the roots into the form ae to the I theta, which is the polar form, and what will happen is that one of 2 things will happen. So let's have a look at the Argon diagram here. So let's imagine that we have here e to the I theta, and we have here e to the minus I theta, where that is theta and that is theta. Then basically we know that e to the I theta add e to the minus I theta equals 2 cos theta. That's something that's worth bearing in mind. Again, if it doesn't mean anything, please go and watch our complex number videos. The second thing that you have to be aware of and remember is that when we have something here theta, e to the I theta, and we have something here theta e to the minus, well, that would be e to the I pi plus theta, my apologies, then basically e to the I theta add e to the I pi plus theta is equal to 0. They cancel each other out, and we will use that all the time, and it will be used to simplify this thing here. And the third thing that you need to know, let's just put it in here, is obviously there's 2 pi in a circle. So if this is theta and that's e to the I theta, then it's also, if we go round completely one more, it's also e to the I theta add 2 pi, and it's also e to the I theta add 4 pi. So we can take multiples of 2 pi out of these powers to make it easier. So let's get on with the actual question. X squared add root 6x add 3 equals 0. Okay, so let's go x squared add root 6x add 3 equals 0. So therefore we know that alpha and beta will equal, by the quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a, which simplifies as minus root 6 over 2 plus or minus I root 6, well, that's over 2, my apologies, and therefore looking at this, we can take out the root 6 over 2, which gives us minus 1 plus or minus I. And again, looking at the Argon diagram, minus 1 plus or minus I here, well, here's minus 1, here's I, and here's minus I. So there's minus 1 plus I, and there's minus 1 minus I. By Pythagoras, that modulus is root 2. So therefore we know that alpha and beta are going to be equal to, well, let's say alpha is going to be equal to root 6 over 2 times root 2 e to the I 3 pi over 4, and beta is going to be equal to root 6 over 2 times root 2 e I to the 5 pi over 4. And that's just converting between the standard complex number and the polar complex number. Okay, so now what we need to do is we need to take a look at alpha to the 23 add beta to the 23, which is in the question here, and hopefully it's going to simplify. So alpha to the 23 add beta to the 23. Okay, well, let's have a look. So basically, let's just simplify this. Root 6 times root 2 over 2 is equal to root 3 e to the I 3 pi over 4, and then beta will also be root 3 e to the I 5 pi over 4. So that's alpha, and that's beta, just simplifying the third there. Okay, so alpha to the 23 add beta to the 23. Let's have a look at that. Well, it's going to be root 3 to the power of 23. And then looking at alpha, we're going to have e to the I. Well, 3 pi over 4 to the power of 23 is going to be 69 pi over 4. Add, and then for beta, e to the I 5 pi over 4 to the power of 23 is going to be e to the I 115 pi over 4. Okay, which equals root 3 to the 23. We can take out multiples of 2 pi, which is 8 pi over 4. Well, that will leave us with e to the I 5 pi over 4. Add e to the I 3 pi over 4, taking out multiples of 8 pi over 4. And looking at that, basically in an Argon diagram there, that is that, and we've already discussed that that will therefore equal 2 times the cos of that, and the cos of that is 1 over root 2. So all of that thing there is root 3 to the 23 times 2 times minus 1 over root 2, 1 over root 2 being cos of 3 pi over 4. So that is alpha to the 23 and beta to the 23. Let's just keep that one there. Now let's have a look at alpha to the 14 and beta to the 14. Okay, well that equals root 3 to the power of 14 times by e to the I, this time it's 42 pi over 4, add e to the I 70 pi over 4, which equals root 3 to the 14, e to the I 2 pi over 4, add e to the I 6 pi over 4. And we've already discussed that. Well, 2 pi over 4 on the Argon diagram is here, and 6 pi over 4 is here, and so therefore those two cancel each other out, and that equals 0. So that's good. Phew, that's simplified things. Alpha to the 15, add beta to the 15, we're now on the bottom, is root 3 to the 15 times by e to the I 45 pi over 4, add e to the I 75 pi over 4, which equals root 3 to the 15 times e to the I 5 pi over 4, add e to the I 3 pi over 4, which we've already seen above there, so we know that that one is exactly the same as that, so that equals root 3 to the power of 15 times, from here, 2 times minus 1 over root 2. Okay, and so that's alpha to the 15 and beta to the 15. And finally, we have alpha to the 10 add beta to the 10. Well, that is root 3 to the power of 10 times by e to the I 30 pi over 4, add e to the I 50 pi over 4, which equals root 3 to the 10 times e to the I 6 pi over 4, add e to the I 2 pi over 4, which we've already seen from above here, is equal to 0. Okay, so basically we're almost there now. All we've got to do is collect it all together. So that in that horrific thing up here basically is just a to the 23 add b to the 23, add alpha to the 14, add b to the 14, which we know is 0, over alpha to the 15, add b to the 15, add alpha to the 10, add b to the 10, which we know is 0. So basically this whole thing simplifies to root 3 to the 23, where was it? Sorry, root 3 to the 23 times minus root 2 over root 3 to the 15 times minus root 2, which equals root 3 to the power of 8, which equals 3 to the power of 4, which equals 81. And hey presto, that answer is answer number 1. And that's the correct answer there. Okay, now in actual fact, let's do another one, because on the same paper, there was a Shift 2 paper on a JEE Main, and it will just reinforce what we can do. So here it is, if you want to pause the video, have a quick go at this. Okay, now checking very briefly that b squared is less than 4ac, so we would use this method. Well, root 2 squared is definitely less than 4ac, so we do use it. So let's have a go. So basically, alpha and beta are going to be equal to root 2 plus or minus root 2 minus 8 over 2, which equals root 2 over 2, 1 plus or minus root 3 I. Okay, and again, this is one of the 16 must-know complex numbers. If you haven't watched that video, I implore you to go and watch it, because these 16 complex numbers appear everywhere all the time. So we know that it is basically that number there and that number there. So we know that alpha is root 2 over 2 times 2e to the I pi over 3. Just basically that is that number there in polar form. And beta is root 2 over 2 times 2e to the I minus pi over 3, or minus I pi over 3. Okay, so this one's a bit easier actually. All we need to do is alpha to the 14 add beta to the 14, which equals let's just cancel this out here, so that's root 2 to the power of 14 times e to the I 14 pi over 3 add e to the I minus I 14 pi over 3, and we can take out multiples of 2 pi from that. So that equals 2 to the power of 7, well, root 2 to the 14 is 2 to the 7, e to the I 2 pi over 3, add e to the minus I 2 pi over 3. And if we look at that on an argon diagram, we get 2 pi over 3 is here, and minus 2 pi over 3 is here, which means that basically that there is going to be equal to 2 cos of 2 pi over 3, and cos of 2 pi over 3 is minus a half. So basically here the answer is going to be 2 to the power of 7 times 2 times minus a half, which is the cos of 2 pi over 3, which equals minus 2 to the power of 7, which equals minus 128, which is answer 3. And so there we go. So you can see actually once you get used to them, they are relatively straightforward. You have to be careful. What you need to look out for is here, here, and the multiples of 2 pi, and go from there. And remember, most importantly, is you have to check that b squared minus 4ac is less than 0, because if it's not, then you use a completely different method. I hope you found this useful. If you have, please like the video and subscribe to the JEE Academy YouTube channel. Thank you.